Hello and welcome. Today we're going to talk about TeamSpark Workbench agent to agent or A2A support. We'll get a little bit of overview of what A2A is, and then we'll discuss how we implement it in TeamSpark Workbench. So first of all, A2A is the agent to agent protocol. It's an open protocol that lets agents collaborate with each other and delegate to each other. It was launched by Google in April 2025 with a bunch of technology partners, pretty much everybody except OpenAI. That was later transitioned to the Linux Foundation for governance, which people were generally pretty happy with. It's based on existing standards. It's a pretty straightforward protocol. It's over HTTP, uses SSE, JSON RPC. It's a lot like MCP in terms of a protocol. A big difference is it has security baked in from the start, unlike MCP. It supports long-running tasks and multimodality, so not just text, but images and other kinds of modes. So it's a pretty comprehensive protocol, pretty simple and straightforward, that allows agents to call each other with subtasks and to collaborate. And so just in terms of how it works, we have client agents and we have remote agents. So a client agent is sort of a normal chat interactive agent like you use now, like ChatGPT. And a remote agent is just another agent that's set up to handle some specific set of tasks. It'll usually have some context and some prompts and maybe some tools to accomplish that tasks. So what happens is that your client agent will enumerate the remote agents over A2A, over the protocol, and each remote agent will come back with an agent card that expresses its metadata and its skills and its sort of area of expertise. And then the client agent will call those remote agents when it has appropriate subtasks for them to do. And that could be a task to go accomplish something. It could be a task to just return some information, answer a question. And then the remote agents will then get those subtasks, they'll process them, and they'll return a result without disclosing any of their inner workings. So if they call tools or access resources or any of the sort of chit chat that you see back and forth as an agent solving a problem, you're not going to see any of that to the client agent. You're just going to get the result. And then the client agent will consolidate those results. So it'll either build them into your answer, or if in the case of tasks being accomplished, it'll understand, which subtasks have been accomplished. So it's basically a pretty straightforward way for a traditional agent to call other agents when it needs them to do some specific kind of work. And it can call many agents. Those agents can use tools. Those agents can call other agents. You can sort of imagine like a big tree of these things to accomplish more complex tasks. So how does it relate to MCP or Model Context Protocol? A2A is agent to agent. MCP is agent to tool. So really, A2A is about collaboration between agents. And it's when you have a task that is complex or goal-oriented or requires multiple steps or maybe some kind of reasoning or usage of multiple tools. So you can think of it sort of as if I'm an agent and I need to call another agent that's going to have to apply some complex process to be able to accomplish the task or answer the question. I want to use A2A and delegate to an agent. If I just need to call a tool to get a simple answer, then I'm going to use MCP for that. So MCP is really just allowing agents to access external tools and data. It's in a highly structured way. It's very much like an API call where you say, this is a tool, here's what parameters it takes, here's what the return value looks like and what everything means. So for doing things that are kind of simple. So you can think about if you wanted to know what the current temperature was in a city, that's a pretty straightforward tool call. You're just going to call an API and say, hey, here's the city, what is the current temperature? And you're going to get back an answer. It's very straightforward. If you wanted to plan a vacation, which meant you need to find an appropriate city to travel to based on either the weather forecast or the typical temperatures for the time of year that you're going to go, that's a more complex task, right? That isn't just, here's a question I need an answer. That's go do a little research and think about this and maybe get data from multiple sources. So that's something you would have an agent do. So they're really used for two different purposes, but they're almost always going to be used together. They're complementary technologies, and most agentic systems will use a combination of both. They'll use tools for simple things. They'll use agents for more complex things, and the agents will use tools via MCP. So let's do a quick review of TeamSpark Workbench, because I'm going to talk about A2A in the context of TeamSpark Workbench and do a little demo just to remind people what it is. It's a no-code agent creation platform. It allows you to use any model, including hosted models and local models. It's fully customizable. You can tweak everything about the way that the models work, all their settings and prompts. It allows you to do pretty sophisticated context engineering through rules and references. So these are systems that we have in place that allow you to build rules, much like you'd have for a coding agent, about how the agent ought to operate, and references, which is collections of ground truth. And the TeamSpark agents can actually build their own rules and references as they go if you choose to enable that, so they can sort of learn as you use them. It supports tool usage via MCP. We have a pretty sophisticated tool usage, including tool, granular tool permissions and visibility, all that sort of thing. And it's a client app, so there's a GUI app and a CLI that's available on all platforms you can download. So our goals with TeamSpark Workbench for A2A were twofold. First, we wanted to allow our TeamSpark agents to be able to orchestrate other agents, either TeamSpark agents or other agents using A2A. So basically to be able to have TeamSpark be able to delegate to sub-agents over A2A. And then the second one was allow TeamSpark agents to be served via A2A and usable by any agent supporting A2A, whether it's TeamSpark or not. So if you had a TeamSpark agent that you built to do something specific and you wanted to plug that into Gemini or something else that knew about A2A, we wanted to be able to do that as well. And to get into sort of how we did that, about a month ago, we did a project where we extracted all of the agent technology out of the application and into a pure JavaScript, TypeScript API, SDK, basically. So we built this thing called Agent API where we completely separated all the UX and all the application framework from the actual just pure agent implementation. So you can create an agent via code from any JavaScript or TypeScript environment. The agents are backed by a serialization strategy. So there's sort of a framework for it. The file system strategy we built is built in and shipped with it. So if you want to build an agent on top of the existing file system agents that you can build with the app, you can just use those agents directly. So you can go into the app, build a no-code agent that's fairly sophisticated, do whatever you want, and then you can use Agent API to just run that from your own code in whatever way that you want. Anyway, pretty cool. We didn't really know exactly what we were going to do with this when we built it, but it turns out there was something useful to use it for. And that is that the first part of this is that we built an A2A server. So we basically built a server that sits in front of TeamSpark agents using the Agent API. So essentially fires up the TeamSpark agents over Agent API, and it adapts them to the A2A protocol. So it implements the A2A server protocol and calls the TeamSpark agents over the Agent API. So A2A server is a separate package in our main repo. You can use it now. It's available as an API and a CLI. Its configuration is pretty simple. You just give it a list of agent file paths and an optional port. And it also supports what we call multi-agent mode. So we noticed as we were firing a bunch of these things up that if you have a lot of agents running, the default way that the A2A server SDK works is it fires up an Express app for every one of them. And that seemed a little cumbersome, especially kind of dealing with lifecycle management. So we built a mode, which is if you pass multiple TeamSpark agent file paths, it puts them all on a single Express server at different paths. And then both the API and the CLI, when they start up, it expresses like, here are the servers that we're serving and the paths that they're at. And I'll show you what that looks like right now, just in case that's not entirely clear. So we're going to run this command here. So we're just going to run the A2A server app. We're going to pass it paths to 2 of our TeamSpark agents and give it a port number. And when it runs, it's going to basically tell us the multi-A2A server started successfully. It's running on this port. There's a discovery endpoint. This is not a standard protocol thing. It's just something I implemented sort of for test. And we found 2 registered agents. So the agents are these 2 agents, and each one has a path. So this is sort of the normal path that you would plug into anybody that was going to use A2A. Any A2A client that needed to find an A2A server, this is the path that you would give it. So we're actually running both of these off of the same host and port, same endpoint. The second phase of this is that we built an MCP server to orchestrate A2A agents. So the thing you might be thinking is, well, let's say I have an agent, but it doesn't know anything about A2A, and I want it to be able to call other agents. How is it going to do that? And the answer is, well, you're going to give it an MCP server because your agent will know how to use MCP, and that MCP server will allow it to enumerate the agents it has access to and then to call those agents. So we have a pretty straightforward MCP server. You give it a list of A2A agent HTTP endpoints. So you can basically give it these endpoints that we found right here, and it will serve those via MCP to any agent. So this is not a TeamSpark specific thing. This happens to be how we use it, but you could use this A2A MCP in any LLM that supported MCP, and through that be able to give it A2A. client support, so we can use A2A servers and delegate to other agents. So that's kind of cool. The other thing that we did was that it was a little bit cumbersome to have to run A2A server to set up the server endpoints and then plug those endpoints into the MCP server. So we built a little bit of custom support. So when you configure your MCP server, you can either give it the A2A agent endpoints, just nothing TeamSpark specific, just point it to any A2A server, or you can give it a file path, either a file URL or just a file path to a TeamSpark agent. And if you do that, it'll actually use the A2A server API to host the TeamSpark agents as A2A agents. So I said A2A like a lot of times in there, but basically I can set up this MCP server and say, hey, here's an A2A server endpoint, or here's a TeamSpark agent or a bunch of TeamSpark agents. And all you have to know is that it's then just going to magically make all those agents available to the LLM, the agent that's using the MCP server, or in our case, it'll be TeamSpark. So I'll talk a little bit about some of the changes we had to make. We made a change in the agent configuration in TeamSpark so that the user indicates whether it's an interactive or autonomous agent. So interactive meaning just a normal agent you chat back and forth with, and autonomous meaning this is an agent that's a remote agent whose job it is to essentially solve a problem, complete a task or return information without interacting with the user, without maintaining any context or state. We added the agent metadata that we needed for the agent card to support the protocol. I'll show you what that looks like in a second. We had to work on system prompts. So both for orchestration, meaning to tell the agent that it had access to A2A and that it had access to find other agents and delegate. We had the tool descriptions weren't enough to cause the agents to use those tools consistently. So we had to build system prompts to drive that orchestration to basically tell the model, hey, you have these tools, you should always use them and always defer to them if they have expertise instead of trying to solve the problem yourself or failing to give answers or giving incomplete answers. So we had to write some tooling around that. And then we had to write some prompting around autonomous agents. So if you are an autonomous agent, we also had to write some prompting to make sure that the agent understands that it's essentially needs to complete this task without interacting with the user, no partial responses, no clarification, no tool permission usage, that sort of thing. And an agent can be both, right? An agent can be an autonomous agent that also orchestrates other agents. So you can sort of imagine this tree of agents, and one of them might be some agent that knows how to do some complex task that you're going to call via A2A, and that agent might call other tools and agents to do its job. So we had to use system prompts and do a little bit of prompt engineering to get all that to work properly, and I'll show you what that looks like. And we did some work around tool permissions and enablement. So autonomous agents only see tools that don't require user permission. So we assume that the agent's going to be configured in a way that's proper, and however you have tool permissions set up, those autonomous agents are only going to see the tools that don't require permission. So for those agents, you have to be a little more careful about what you enable, but you generally want to turn off permission request requirement on any tools that you want the autonomous agents to be able to use. And also, autonomous agents can't use tools that mutate agent state. So the autonomous agents don't have any state. They don't have any like chat session context, and they can't mutate the agent state. So they can't like create rules and references or delete rules and references or things like that. So we built in fine granularity tool permission, so we can basically turn off those tools that mutate agent state, so they're not presented to the autonomous agents. So we basically just built enough support, which not a ton of stuff, but enough little sort of feature support within TeamSpark that we can actually build these profiles of the right kind of tools and the right system prompts to make both of these modes work properly. So we'll give a quick demo. I'll start with showing, so we sort of showed what this looks like, how we get the endpoints when we run the A2A server application. And so I'll show what that looks like in ToolVault. So ToolVault is another TeamSpark product that's an MCP server security product, but it has a nice tool configuration interface, a little bit nicer than the TeamSpark Workbench. So we're going to show this in both places, but we'll show it here. So we have our A2A server, MCP server set up, just a standard IO, pretty simple server. And its configuration is, it's essentially telling it where to find the source code. Eventually, you'll just be able to run this via an NPM package, but we're having some issues with publishing it right now, so soon. But you can run it from source, and then the configuration is just the endpoint. So in this case, that's one of the endpoints that the A2A server fired up. So we're just telling it, hey, go look here, and you're going to find an A2A server endpoint. And if we look at the startup logs, we can see that when we started the server, it found that one endpoint, and this is the agent card for that. That's kind of chatty. We'll turn that down later. And then if I go into like my A2A MCP server, I can see that its tools are essentially list agents and send message. So if I do list agents and run that tool, you can see that it found one agent, which is the one that we ran. And if I go look at the raw, you can see that. So we get back from these tools simple text responses, but also structured content. So the API definition expresses that it's going to get this, much more detailed structured content. So the LLM actually gets the full agent card back for each agent, which has capabilities and skills and a bunch of other information. So you can see that we were able to run a TeamSpark Workbench agent using the A2A server, CLI, and set that up in an environment, in an MCP environment where we can now use that to see, hey, there we have this, and we could call send message and actually send a message if we wanted to, but we're not going to do that right now. So let's go look at TeamSpark Workbench itself. So we have our agent management tab, which is just showing us the agents that we have in our workspace that we're working on. I'm going to show you a few of them. I'll start out with what we call the orchestrator agent. So this is just the top level agent that I'm going to chat with. And it's a super simple agent. We've got some agent metadata, which isn't really used for anything. And then we have it set to interactive. So it has no references, no rules. The only tool it has is the A2A MCP tool. And if we look at what that looks like, it looks just like it looked like when we did the demo a second ago. So the way it's configured is that it has two A2A servers, or two that it's looking at. One of them is just a file path to a TeamSpark Workbench agent, and the other one is one of these ones that we're running off of the A2A server command line app that I ran a second ago. So it has access to these two servers. Now I could just put both of these in as pointing directly to the TeamSpark Workbench, and it'll run them from TeamSpark Workbench as opposed to like using an A2A server itself. And I could just actually not even put in the file :URI and just give it the pass, and that would also work. So it's pretty straightforward. You can just sort of type in any combination of TeamSpark Workbench agent paths or actual A2A endpoints, and the MCP server will find them and work properly. And again, we have the list agents. So I can run it, and I can see the agents that I got back, and I can send a message to the agent if I want to. Again, I'm not going to do that here. Let me go show a couple more things before we actually complete the demo. So these agents that we're going to call, I have an agent called Bob Expert. Let's go look at that. And this is an agent that is an autonomous agent. So it tells us what its name and version and some more metadata. And it says it's autonomous, and then it has some skills. So it has a skill called Bob Facts. I can provide answers to any questions about Bob, and it has some tags on it. So we have everything we need to build an autonomous agent configured here. And then it has just one reference, which is just a bunch of facts about me, and that's it. No rules. Okay, markdown formatting rule. No tools other than the built-in rules and references tool. So super simple. This is just an agent that has a little bit of context that we built up through a reference. And then I have another one called the TeamSpark. So this is an agent that I built to build the TeamSpark website. So it has a bunch of references. Some of these I typed in, some of them it built itself by reviewing things in the file system and other information. So it basically has a nice little cache of information of ground truth about the TeamSpark Workbench product. And then it has some rules, and these rules are mainly about how I wanted it to build the website. So I didn't really teach it how to code, but I did give it some information about how I wanted it to put the website together, and it has access to some basic tools for coding, file system, and grep to be able to build the website. So this is a tool that's meant to be an expert on the product, so it can answer questions about the product, and also it was used to build the website, which that we're not really going to leverage that too much here. But again, if I go to settings to agent info, I can see that I've got a bunch of agent info. And this is an agent that's an expert on the TeamSpark Workbench product. It doesn't have any skills, so the default skill will be created when we go to use that. So if we go back to the orchestrator, when you install the A2A MCP server in tools, this orchestration tab will pop up. And this is just basically a little bit of UI sugar to make it easier to interact. You could do everything you needed to do from right here. So you can list the agents and see the complex sort of result you get back, and also send messages to test them here. But we just provide a little bit nicer user interface here. So what we do when you go to orchestration is if you're orchestrating other agents, we provide this tab that allows you to see, hey, I am connected to I am running the A2A MCP server, and I have 2 agents that I found. I can reload them. And if I go to those agents, I can essentially see what they look like. So it's going to go find, it's going to get the icon and the name and version and ID, the description, basically all the metadata. So this is essentially the agent card in the A2A protocol. It's everything that the agent exposes. And you can go, look at the docs and that sort of thing. And then it'll show you the skills that it has. So again, the TeamSpark agent didn't have any skills, so it built a default skill that's just general conversation and assistance. That's what you get if you don't define a skill. And if I go to this Bob Expert one, I can see sort of the same thing, except it actually does have the skill that we showed. And the other nice thing is I can actually test these agents here. So I can say something like, so that's a pretty terse answer, but that's kind of what you sometimes get from these agents. So the agent is just going to give you back the direct answer with no fluff. And then the client agent's going to go ahead and consolidate that and build the actual response it shows to the user. But this just shows that I was able to use the MCP server to get the sub agents configured, and then I can go through this orchestration and see their agent card, understand how the agents interact and what they look like, and I can actually test the agents right there, which is kind of handy. A lot easier than doing it through like that interface. And then for the last thing, let's just say, I need to come up with some better demos, but let's just try this. So let's just say, tell me about TeamSpark Workbench and its creator. Also point out that these are all using different models, not for any particular reason, but our orchestrator is using Gemini 2.0 Flash, and some of the other submodels are using Claude and other models that just make more sense for those particular sub-agents. The other thing is, because I'm running this in debug mode, I have a lot of telemetry and a lot of logging. So this is the A2A server, and this is sort of all the chatter that's going on with the A2A server when I'm running it. So it makes it easy to kind of debug what's going on with these agents. Normally, you aren't going to have this because the whole point is that the sub-agents are supposed to be opaque. But let's see what happens. So it called list agents, and it got the list of 2 agents. And then it called each of those agents. So this one said, tell me about TeamSpark Workbench, and I got back a pretty comprehensive answer from the TeamSpark agent. And this one says, tell me about Bob Dickinson, and it got back of basically what the agent knows about me. And that answer, and then it consolidated that and essentially said, this is some information about the product, and here's this guy and what we know about him. So it's not like a rocket science example, but it's basically we took an agent, an orchestrator agent that doesn't know anything about anything, doesn't have any context, doesn't have any rules, references, tool usage, nothing. The only thing it has access to is 2 other agents, and those agents each have some context and some tools and some expertise about some particular topic. And this top level interactive agent was able to call those sub agents and, perform a task and gather some information. So obviously you can imagine much, much more complex, sophisticated use cases of this. But this is just showing the sort of basic proof of concept end to end that yes, we can install our MCP server. We can make the agents available to this agent. And this could be it doesn't have to be TeamSpark agent. This technique of using the MCP server, to serve agents to other agents will work with any agent that supports MCP. And then we showed sort of the end-to-end. You can test it, review the agent cards, and then actually go use the thing in real life. So that's kind of the end of the demo, the end of the presentation. TeamSpark Workbench with the A2A support that we've shown is released and available. So you can go to the website and download the app and run it and play with it. The tooling we have basically 3 pieces of tooling. We have the agent API, which is the standalone SDK that allows you to run our agents, pure JavaScript, TypeScript environment anywhere you want from your own code. We have the A2A server, which is both an API and a command line app that lets you run those agent API agents as A2A server agents. And then we have the A2A MCP, which is a little more general purpose. It is kind of somewhat specific in that it knows how to run our own agent API agents, but it also will just make any A2A server available to any agent that talks MCP. So this is a little more general purpose that people might use outside the scope of TeamSpark. All 3 of these things are in the repo under the packages, under the mono repo, and you can feel free to play with them. They're pretty straightforward. They've, normal sort of node SDK organization, so they're not hard to figure out. Our plan is to publish these as individual packages, so you can just npm install any of these things. We're having some issues with npm with our organization, but as soon as we get that squared away, we'll also publish these as packages. So hopefully that's been instructive. A2A is super cool. It's fairly straightforward. It was much easier to implement than I sort of suspected it was going to be. The kind of pathway of using MCP to make A2A support available to the agent was probably one of the keys there. Anyway, enjoy. Thanks.